topic today is distribution system, uninterruptible power, uninterruptible primary power. You would have a distribution voltage system that would provide continuous power delivery to critical loads, including a system fault. I'm talking about a loop system where you have a cable fault on it, and we still continue to serve power to all of our customers. A zero-cycle interruption, uninterruptible primary power. Let's look at a closed-loop system, a primary network. First of all, there is no open point in this loop. This substation is tied to this other substation continuously. You don't have to have two different subs. You could have two feeders out of the same substation feeding the loop. That's common. But you could also have 3 or 4 different substations feeding this loop. There's really no limitation. The more sources of power you can bring into the loop, the better the system reliability will be, the more alternate sources of power that are available. Nothing that I'm proposing today is new and that doesn't work. It has been proven in the field, and we've got good references for you to talk to. Shouldn't be worried about that. Okay, that's one subject. Another thing is power quality. Let's look at this load right here. He's not only being fed by this substation cable, but he's also getting power from this side as well. He has twice the copper, twice the cable going to his load. Half the system impedance feeding that load. And because of that, it's such a, I call it a stiff system, such a stiff system that primary network users, they don't get complaints about voltage flicker. Let's take a look at something else. What happens when we have a fault? Well, we're going to get fault current contribution from both of these substations, aren't we? And the available fault current is going to be whatever your system voltage is divided by the fault impedance. That's going to give you your maximum available, it's Ohm's law. That's what your maximum fault current is going to be. And it's not going to be infinite. If this was a zero impedance, we'd have we'd have fault current, max fault current coming from both subs. It just doesn't happen that way. And let's just throw out a number. Let's say that our system voltage divided by our fault impedance is 10,000 amps, available fault current. If this were an open loop system or a radial, remember we had an open point here, all of that 10,000 amps has to go through our elbows and cable and equipment to get to the fault. In a closed loop system, we share that current from both sides. And this isn't exacting, but my point is you've got maybe half, or close to maybe only 5,000 amps going through the equipment instead of 10,000 amps like you would with an open loop or radial. When we have a cable fault with a primary network, these are all circuit breakers. And typically you use a circuit breaker for your load, but also the source ways are also circuit breakers, not just load break switches. They have fault interrupting capability. So, when we have an event, our relay senses where the fault is, opens the breakers up on either side of that bad section of cable. That does two things. It isolates the bad section of cable, but it also interrupts the fault at this section. The substation breakers do not open. It's a local operation for just that line section. And we never lost power to the loads. We never lost the sine wave going to our customers. They're all set up for SCADA. All you have to do is add a fiber optic line out or some kind of a twisted pair, to the switchgear. Here's an example of switchgear. Close up of it, show you what it looks like. This gear is available in pad mount or submersible application. It's available liquid filled or SF6 filled. It's almost always stainless steel. So there is a solution. There is a low-cost solution for uninterruptible primary power. It's available today. It's been available for 60, 70 years. It's a combination of the Trayer VFI switchgear and Trayer's own PLP pilot lighter relay. This combination is the lowest cost, industry proven, and we've got them out in the field working, uninterruptible primary power solution.